All right, welcome everybody. So in this video, we are going to keep working with changing from two different bases for a vector space V and finding a matrix, which is going to allow us to change from coordinates relative to one basis for this vector space into coordinates for a second basis. And thus far, we've been working with an example in R2, but now I want to generalize this to more abstract examples. So here, let's imagine we have a vector space V, which we don't even know what it is. It's some arbitrary vector space V, but what we do know is that it has dimension 3. So here's one basis for this vector space that contains three vectors that we'll just call A1, A2, and A3. We have no idea what these are, but we know that there are three vectors that make up this basis A. And we have some other basis B, and it also has three elements, B1, B2, and B3. And in particular, we know what the B coordinates are for each of the elements in matrix A. So I know that A1, we can write this as a linear combination of elements from basis B. And let's imagine that we're told that A1 is equal to 4B1 minus B2. And we're told that A2 is equal to minus B1 plus B2 plus B3. And lastly, we know that A3, that is equal to minus B2 plus 2B3. So sorry, there's a negative sign in front of the B2 plus 2B3. And let's say, for example, I have a vector x in our vector space V, and I know what its A coordinates are. I know that this vector x is 3 times A1 plus 4 times A2 plus A3. And I would like to express this same vector in terms of B coordinates. So what weights would I need to combine B1, B2, and B3 to get this same vector x? So we need to find a change of basis matrix to go from A coordinates into B coordinates. So one way we've set up this change of basis matrix would be to go from A coordinates into vector space V using standard coordinates and then move back down to basis B by taking the inverse of the change of coordinates matrix from B into standard coordinates. So PB inverse goes from standard coordinates into B coordinates. That's not going to be particularly helpful here because we don't know literally what vector space V is. So I don't even have a standard basis for vector space V. And we don't have any concrete values or notion of what these objects are. So let's use the other result, which tells us, well, if I know how to take each of these basis elements from basis A, and I know what their B coordinates are, then I should be able to set up the change of basis matrix by pulling off the B coordinates for each of the basis elements in basis A. So for example, I know that the B coordinates of A1 are 4, minus 1, and then there's no B3 component to it. And the B coordinates for the second basis vector in basis A, A2, would be minus 1, plus 1, and then another plus 1. So that would be minus 1, 1, 1. And then lastly, for A3, the last basis vector in basis A, we have that A3 is minus B2 plus 2B3. So writing A3 in B coordinates, we would have 0 since there's no B1, negative 1, plus 2. And now each of these three vectors, the B coordinates for our basis vectors in basis A, form the columns of our change of basis matrix. So now our change of basis matrix would have first column given by A1 written in B coordinates, and that was 4, minus 1, 0. And then the second column would be minus 1, 1, 1. And the third column is 0, minus 1, 2. And again, all of these weights we're getting from the given information. We were given the B coordinates for each of the basis vectors in basis A. So here we've got a matrix which is going to allow us to just go from A directly into B without having to make a pit stop in the standard basis of V along the way. Great, and so now we can answer the second question. So if I know my vector written with respect to A coordinates, so for some vector X in vector space V, I know that it can be written as 3a1 plus 4a2 plus a3. And here I just picked off a random vector to apply this change of basis for. And we would like to express x in terms of what are the weights that we would need to combine b1, b2, and b3 to get this same vector back in relative to basis b. So now I've got this change of basis matrix. So I have a vector which is written in A coordinates as 3, 4, 1, and I'm getting this from the 3, the 4, and the 1 being the weights in front of A1, A2, and A3. And now we can apply our change of basis matrix to the vector 3, 4, 1, which is written with respect to A coordinates, and get the corresponding vector, same vector back, just written with respect to B coordinates. So if I take 8 times b1 plus 0 times b2 plus 6 times b3, what we can see is that would be the equivalent of going 3 times a1 plus 4 times a2 plus a3. So here's how we can go from A to B directly without knowing what a standard basis for vector space V is.